Hello student, my name is Sumit Mehta. So in today's lecture we will discuss about fundamental theorem of calculus. Okay. So as in the previous lecture we have defined a to b f of x dx represents the area bounded by the curve y equal to fx between the ordinates x equal a to b. Okay, so this is x equal to a and this is x equal to b and this is the curve y equal to fx. Okay, so this area is being represented by the integral a to b f of x dx. So based on this definition, the two basic fundamental theorems have been given. So we will discuss the first fundamental theorem of calculus, which states that let f be a continuous function, let f be a continuous function on the closed interval a to b, and let a of x be the area function. Then we can say a dash x, or the derivative of x, will be equals to f of x. Okay, because this is represented as ax. So if we derivate the equation on both sides, so what we will get is a dash x will be for all x belongs to closed interval a to b. So this is the first fundamental theorem of calculus, students, because this is representing the area, and if we derivate the equation on both sides, what we will get is a dash x will be equals to f of x. And the second fundamental theorem is, okay, let f be continuous function, which we know, let f be the continuous function defined on the closed interval a to b, defined on the closed interval a to b, and f be an antiderivative of f, then we can say that then integral f of x dx, let me change the color, a to b, will represent f of x a to b, or you can say fb minus fa, where capital F is the antiderivative of the function fx. Okay. So I hope, students, now you are pretty clear about the two fundamentals principle of the calculus. Okay. So according to the second principle, we will solve most of the questions, or to find out the area that is represented by this definite integral. Okay. So let me give you a simple example on this, and in the next lecture we will do some more questions on these. Okay, students, this is the first very basic example on to find out the area under the curve by definite integral. So first, what we will do, we will use the second fundamental theorem of calculus, which states that there exists an capital F, which is the antiderivative, or you can say the integration of the function that is given to us. Okay, so with when we will integrate this function, we will get x cube by 3, and by applying the limits 2 to 3 in this, okay, so the integrand was fb minus fa, so we will get is 3 cube by 2 minus 2 cube, so which is 27 minus 8, that is 19 by 2, 19 by 3, sorry. Okay, so I hope students that you're pretty clear about the second fundamental theorem of calculus, which we will be using further also. Okay, and stay tuned for the next lecture on the questions based on these fundamental theorems. Thank you students, happy learning, stay blessed.